12 friends. 12.
Friends or days?
12 days. 12 friends. That's a lot of friends. Come on now. I wonder if any of you remember, like, back to 6th grade when I would, like, sometimes go into your classroom and I was like, do you know that you have 2,200 and blah, blah, blah days until your AP exam?
Yes.
We have 12 left. Where have they gone? These days are gone. But it was really exciting because I got to meet a new 6th grade friend named Eric yesterday who came out of a place called Wall Street. And I was like, you're going to take the AP exam in 2,203 days? And he was like, what? I mean, who knows? He's in Wall Street, so anything could happen. Anyway, life is good. And if you didn't hear the news, yay, gonna be a dad again. No, I'm not yay, really excited. Yes, very distracting information to have rolling around in the brain when there are 12 days left. Anyway, more information to come on that, but know that my top priority is you all. Ooh. And you all out there in the world getting you ready for this magical experience that is the AP exam. David, you've got those free response questions for me that I gave you yesterday that I said you need to do these 3 if you weren't able to stay for our AB review session yesterday.
No.
You can have until tomorrow to get that done.
Okay.
Okay, after that, Circus Boy Crazy will arrive. Calculus survival guides need to start coming with you every single day starting on Monday. Tomorrow is the last day of any new material. After that, we are in 100% review mode. The survival guides need to be here. I'm also planning to update the BC survival guide component. Like there's like 30 pages in there. What I did is I added all the links to all the videos that we filmed for series, parametric and polar. For the BC friends out there, your calculus teachers are going to get you a new copy. All that's going to happen. All right, tonight's homework is assignment number 136, and the problem set conveniently sandwiched between 135 and 137. All right, so let me pass back the homework, and I want to talk about something with partial fraction decomposition. And if you guys can take out all your calculus stuff. David, here you go. Okay, Lewis, Stephen, Myra. Oh, and then there's a whole bunch of you that didn't put names on assignments. I don't know if it was your little test to see how well I know your handwriting. And the answer is, I only know Carmen's handwriting for sure. She has very distinctive handwriting. Everybody else, if you're not getting back the assignment from me right now, it's because it just says name. If you get a note that says something like, hey, where are these? It's probably because your papers get separated and I'm not really sure who did what. So I've got 1, here's Andrew, 1, 2, 3 homeless papers over here that if you turned in the partial fraction decomposition assignment to me and didn't get it back, you might want to go over there to that pile. All right. All right, Stephen, if I'm over here, can all the friends see?
Yeah.
Okay. So, partial fraction decomposition, I get the feeling from Tuesday and from grading the homework, it is a very nice, very comfortable thing for all of the friends in the room. Some of you are like, I'm smart again. Yes, this happens. Once the series unit is over, everybody starts to feel smart again, and you're like, this is why I like math class. Yay! Now, here's the thing. Multiple choice question number 4. Most of you, when you did the partial fraction decomposition, got to this part. In fact, if you want to look at your notes, or the homework that I just passed back, most people made it here. Yay. And then blew it because they were in autopilot mode. The autopilot mode people all said, oh, 2 over x plus 2, I know how that integrates. That's 2 times the natural log of the absolute value of x plus 2. And they got over here and said 3 over 2x minus 3, oh, I know how that integrates. That's going to be 3 times the natural log of 2x minus 3. Oh, and because I'm a well-raised calculus BC student, I'll never forget Charlie. Epically wrong. And the College Board was there waiting for you. What's wrong? I want to get some hands on this. What do you see? I see 1, I see 2, I see 3. Why is this not the answer? It is close to the answer, but it's not the right answer, and on multiple choice, you're doomed. Lewis, what's the problem?
The 2x minus 3.
This 2x minus 3, what's wrong with it?
You have to take the derivative of the baby.
Right, this actually would normally be like a substitution kind of question. Your denominator is 2x minus 3. Yes, it's going to integrate and be a natural log of the absolute value of 2x minus 3. But think about the derivative process. The derivative would be 3 times 1 over 2x minus 3. But then you have to multiply by the derivative over here, which is 2. And now you get 6 over 2x minus 3. Is everybody okay? So this really should be 3/2. That one tiny little thing is a common expected mistake. So common, so expected, College Board, evil people that they are. Of course they put that as one of the answer choices, and you walk away and you're like, oh, I'm good.
Did anybody get it right?
Did anybody get this one right? I'm sure people out there get it right. And I'm going to take partial responsibility, not all the responsibility, because y'all are full grown. And I think here's the mistake. When I look at like the lesson material, if I want you to get that, pretty much all the problems we did involved like leading coefficient of 1, and so we didn't have to stop and think about it. And so like what you need, I'd put a little note maybe next to this that says the integral of 1 over ax plus b dx. This is one that I told you guys had to get memorized. The integral 1 over ax plus b is the natural log of the absolute value of ax plus b plus c, almost, divided by a or times 1 over a. Okay, that, like we talked about that on Monday, is like one to memorize, but we didn't get enough practice with this on Tuesday. My fault, my bad. If you are dissatisfied with how you did on this assignment or anything else, you've got until Monday to make the corrections and get it turned into me. Everybody good? David?
So on Monday, I have 8.
You have 8s.
8.
No, I understand. I've been here a while.
I mean, dude, how do I give it to you? Like,
You'll still be here at school. My mailbox will still be here.
Oh, okay.
My desk will still be here. I will still be here. All as well. Anybody else who's going to be out on Monday for apes? One. One, two,
I was like,
three.
why are we out for apes?
Okay, so like won't be here. Easier question. Who will be here? 3, 4 people. Wait, you just raised your hand twice. Okay, so the 4 of you are going to be here. That's fine. It's meant to be a review day. I will film. I will send the video. You guys will watch it. Monday is Miss Hanlon's day. Ooh, I know. It is Miss Hanlon's day on Monday. Tuesday is AP Physics, which is in the afternoon, so who cares? All right. I mean, let's be real. That's the afternoon. That's not my business. Wednesday, there's no AP exams happening that impact you guys.
Not until
Thursday,
your test.
right? And then so after Tuesday, we're cleared till my test.
Yes.
Excellent.
And then
I mean, our test. Wednesday, the following Wednesday, you guys have the AP English exam. I have jury duty.
Boo.
For jury duty? No, it's my civic responsibility.
No.
No,
the
both for
English.
English.
No, you guys are going to do well there. Okay. I mean, you chose the course. Oh, wait, no. Okay. I know. All right, anyway, so like once Tuesday, May 9th arrives, we are in chillax mode. I'm still going to learn. I'm still going to teach. Some of you are I'm going to teach. Some of you are going to choose to learn. Life is going to be good. Okay? But there will be no more homework. There will be no more quizzes. There will be no more tests. You have been waiting for this all of your life. But we're still going to learn, Giselle. All right. So if you guys could find in your head on page 15, I have a new skill. Yeah. Let's see. Right. Okay, so let's put those together, and you can leave them on my desk. Okay. All right, new skill. New skill in the world of integration, and this is called integration by part. I'm going to write out what integration by parts is, and then we're going to tear this apart. Integral of u dv equals uv minus the integral of v du. This is integration by parts. This is the formula. It's what you do. Now, some of you are probably like, what's the u? What's this dv nonsense? What is going on? How is this any better? You start off with an integral, you end up with an integral. This makes no sense. Integration by parts, some people like to talk about this as a double substitution. Yes, so exciting. Double substitution. It's going to be the technique that you use if you see multiplication happening in your integrand and regular substitution isn't enough. We're upgrading your skills here. Okay? And I want to do this a little bit different than the way it kind of falls out in the packet. I'll adjust the packet next year. We're going to look at a problem and we're just going to, we'll go. We're going to deviate. It's crazy. All right, here we go. Here we go. So I'm on page 16 and we're going to integrate x sine of x dx. Where are the folks that might think substitution? No takers for substitution. Usually with substitution, right, you look for not just the, what's the baby, but the other thing that you look for? The derivative of the baby. And so you might say, well, I want to do substitution, and for me, substitution, the u is going to be sine of x. But if u is sine of x and the derivative is cosine of x, there's no cosine of x to play with here. Substitution, not so good. You might say, well, what if u is x? Great choice. Great choice. Clearly it becomes an easier problem if instead of x sine of x dx, it's now u sine of u du. You went nowhere. Here's how integration by, okay, good. I'm glad some of you are with me. Here's how integration by substitution works. Integration by parts works. If you have a multiplication problem, which we have, and substitution doesn't work, then you're going to select something to be the u, and you're going to pick something else to be the dv. Right? Because what we're saying here is the integral of u dv. I know, because I've been here for a while, I'm going to let u equal x and dv equal the sine of x and the dx. According to integration by substitution, this integral is the same as u times v minus the integral of v times du. I'm just asking you to set this on faith for a little bit. I've picked my u, I've picked my dv. I need du. Well, what's du? If u is equal to x, then du means derivative. Du is 1 dx. If dv is sine of x dx, what's v? V is like, where does this derivative come from? V is the antiderivative. So wouldn't this have to be negative cosine of x? Integration by parts says that the integral of u dv is equal to u times v, x times negative cosine of x, minus the integral of v, negative cosine of x, times du. Right now, I'm still just asking you to believe me that this is true. We'll unravel the mystery in a minute. Okay? So let's see, what could I do here? Maybe I want to clean this up a little bit. I've got x times negative cosine of x, and that's negative x cosine of x. There's no integral here. Minus the integral of negative cosine. I'm going to write this as plus the integral of cosine of x dx. This is better than where we started. Why is it better? You can what?
You can integrate.
You actually know how to integrate this part. Back here, the way it was written, you didn't know how to integrate this part. But if I ask you all, hey, what's the integral of cosine of x dx? Everyone's going to tell me? Sine of x. So the answer is negative x cosine of x plus sine of x plus c. Lo and behold, this is the answer to your integration by parts question. Congratulations, friends, we're there. We've made it. First problem. Now, I need you to prove that I didn't just lie to you. I know you're a good man. You're a good.
You wouldn't like to this close to the head.
Am I? How can you prove it? Have a conversation with someone near you. What can you do? How can you prove that I'm not lying to you right now? What do we do? I've moved some things around and told you that the integral of x times sine of x dx is this thing over here. How would you know I'm not lying to you? How could you check the work? We could find the derivative of the thing on the right. If this process is legit, okay, stay with me. If this process of integration by parts is legitimate, if you take the derivative of your answer, what's supposed to happen? You're supposed to get the integrand back. Take a minute, do it, and then I'm going to take 10 minutes and we'll talk. You're here from Mr. Lane, right?
Yeah.
That's good.
Oh, yeah.
Careful with your notation here. We're saying, so this is the check
Oh,
step.
yes.
The check says, if I take the derivative of negative x cosine of x plus sine of x plus c, what happens? Derivative here is a product rule, so negative 1 times cosine of x plus negative x times negative sine of x plus cosine of x plus the derivative of constant is 0. Negative 1 cosine of x cancels out with the positive cosine of x. Negative x, negative sine of x. Hey, that's the same as x times sine of x. Check, I didn't lie. We actually found the antiderivative. Are all the friends mostly okay? Okay. Now, I'm not saying this is my proof that integration by parts works, but what I'm saying is this technique worked on this one particular problem. Everybody okay? This is not a proof of integration by parts. This is an example of integration by parts. Very different. Here comes the proof. Let's go back to the front page. Okay. What I told you in the beginning is that the integral of u dv equals uv minus the integral of v du. I'm going to go over here. The way that you would actually go about proving it is you're going to start, we're going to consider the product u times v. And what I want to do is I want to find the derivative. Well, how would I find the derivative of uv? How would we ever find the derivative of u times v? Product rule. So the product rule says take the derivative of the first. Now be careful. The derivative of the first isn't 1. I'm going to write this as like u prime, or maybe you want to write it as du dx times the v plus the u times dv dx. This is the derivative of u times v. If you're paying attention to this, some of the players are starting to show up on the field. Integration by parts says the integral of u dv equals uv minus the integral of v du. All of these involve products of u and v. Sometimes it's a derivative. The product rule says the derivative of this product is the derivative of u times v plus u times the derivative, the dv dx. Where you're starting the problem is trying to integrate the u dv. So what I'm going to do is I'm going to say, all right, let's go through and let's integrate the derivative of uv. Let's integrate du dx times v. Plus let's integrate u dv dx. Well, the integral of the derivative of this product is just uv. The integral of du dx times v, I'm going to write as the integral of du times v, or if you want, v times du. times du plus the integral over here of u times dv meaning the derivative. Anybody seen integration by parts yet?
Oh, you,
You get to take
That's
the
okay.
U and the V.
Right, this in integration by parts is usually your starting point. Right, you're starting over here, you're saying, I have this product showing up. Well, what I need to do is I'm going to subtract the integral of the v du to the other side. And so by that rewrite process, you get to say the integral of u dv equals uv minus the integral of v du. And seriously, that's it. This is integration by parts. It is a double substitution. You just need to be careful. What is sometimes a little bit tricky is, well, what's the u and what's the dv? How do you make these decisions? And I'll let you guys figure that out. All right. So that's like, that's not why I come to school. I come to school to be told. All right, so show me what you guys can do with example 2 on page 16. Sorry for the back and forth, but I think this is a better way. The Mr. DeRozier that designed all this 2 months ago.
You have to figure that out. You're not going to be
No,
told.
it's figured.
Trust your instincts here, you're going to be okay.
Times V equals U times V. I mean, I said raise, so. Oh. I said raise.
Remember, probably your first move, like you're going to see an integration problem and you're going to think, substitution. Right, but if I'm going to go with substitution, the u has to be something. Maybe my guess is that the u is the natural log of x. If the derivative is 1 over x, that's not showing up in the field. So we need u and we need dv. Anybody want to take a running start at this? What's u, what's dv? You need to make a choice. You need to decide what's u and what's dv. U is x squared. And so dv is all the other stuff. dv is the natural log of x dx. Okay? This is a decision that needs to get made in the front end. Once you've selected u and dv, now you need du and you need v. If u is x squared, it's so weird to say u is x squared. If u is x squared, then du, I think you guys all know, is going to be 2x dx. If dv is the natural log of x dx, what's v?
1 over x.
Oh,
You all fell for it. Let me ask the question again. If dv is the natural log of x, if the derivative is the natural log of x, what's v? What's the antiderivative of natural log of x? And the answer is, you have no idea which is the sign. That this is not the way to pick your u and your dv. There was nothing wrong with what Myra did, other than the fact that if I go with this combination of u and dv, I'm stuck. I didn't get anywhere. So let's block that off. Try it again. What's u, what's dv?
U is the natural log of x.
You're like, I only have one other choice. That's actually not true. U is natural log of x. You guys only see one other choice right now. U is natural log of x. dv is going to be x squared dx. Finish it up. The natural log of x, then du is 1 over x dx. If dv is x squared dx, then v is that antiderivative. V is going to be 1/3 x cubed pulling all of this together, we're going to say that the integral of x squared times the natural log of x dx is u times v, so natural log of x times a third x cubed minus the integral of v du. Is everybody okay so far? We're just moving all the pieces around. So you're not done, first of all, because you have to integrate this 1/3 x cubed times 1 over x. Anybody get some clever thoughts here? 1/3 x cubed times 1 over x. We can actually multiply these together. And if you multiply those together, right, what happens, I want to be really careful here if I'm going to use an equal sign. So this is natural log of x times a third x cubed minus the integral of 1/3 x cubed times 1 over x. Well, that's what, 1/3 x squared. The 1/3 is a constant. I can pull it outside the integral. And then I say, what's the antiderivative of x squared? And everybody tells me. Everyone tells me.
Oh, 1/3.
1/3 x.
Yeah, if you were waiting for the kids at North Central to get loud enough for us to hear them, that was not going to happen, although I think they were trying. So it's going to be 1/3 times 1/3 x cubed plus Charlie. Of course, you can simplify it to 1/9 x cubed. This is integration by parts. Insert Stephen. I was hoping you or somebody else was going to jump in at this point. What do you have to say, Mr. Oriana?
You have to consider the 1 to 2.
Right, what we haven't done is actually consider the limits of integration. Here's the thing I really care about right now, though, is everybody, all 10 of you, really feeling good with this part. Like, it's a process, just like partial fraction decomposition is a process. This is a process. So here's the reason I wanted to hold off for just a little bit, Stephen, on the limits of integration. Is here's what a lot of people will do, and it's a problem. They'll start off their life and say the integral from 1 to 2 of x squared natural log of x dx equals all this stuff. And they'll know to put the limits of integration over here, but they're not bothering to think about the limits of integration over here. This part still needs to be integrated. You need limits of integration. This part has been integrated, and you need to consider the limits of integration here. The way to handle that is by using that big evaluation bar that we've used before. And what you say is this part has to be evaluated from 1 to 2. This notation says, hey, the stuff after has to be integrated, then evaluated.
Also, just use big parentheses at the end and a really big bar.
You could do that as well. There's lots of ways to get around this. So you could just kind of hold off on the end and say, now plug in from 1 to 2 and simplify. The mistake, though, is the kid that says this definite integral equals natural log of x times 1/3 x cubed and forgets the evaluation bar. But then they're going to put it over here. You're linking things that shouldn't be linked together. So it might be a good idea, while we're all still babes in the woods, to handle the integration first, right? Forget about limits, figure out what it's equal to, then do the evaluation separately, and you avoid linking things that shouldn't be linked. Mostly okay? All right, see what you can do the next one. Love being a math teacher. my preference is I just ignore limits of integration until later. Do it any way you want to, just be way careful with the notation. I'm going to pick a U, and I'm going to pick a dv. Okay. U, let's try it and see what happens. If U is x, then du is 1 dx. If dv is u to the x dx, then v is u to the x. My integration then is u times v. It's x e to the x minus the integral of v du e to the x dx. Hopefully that makes people feel pretty good. This is something we can integrate. So we're going to get x e to the x minus e to the x plus c. How many of you guys have that as your antiderivative? We got 1, we get 2, we get 3, we get 4. We get friends. We're in a good place. Okay, check. Check that off the list. Okay. Now, now we need to go a little bit further. Now you actually have to do the evaluation. And so if I'm going to evaluate x e to the x minus e to the x plus c, of course the plus c you don't need. From negative infinity to 0, you're going to have to evaluate. You're going to have to plug in the 0, so 0 e to the 0 minus e to the 0 plus c minus, this is going to be weird, plug in negative infinity times e to the negative infinity minus e to the negative infinity plus c. First part's okay? What's the second part?
C.
C? Negative e to the negative infinity. Negative e to the negative infinity. I can see some of you you're like drawing a little graph, and you're like, maybe you're thinking about the graph of e to the x, right? The graph of e to the x as you approach negative infinity gets close to 0. Okay, sure. That's 0. Negative infinity times e to the negative infinity?
Also.
This part is negative infinity. This part is getting close to 0. Infinity times 0
0.
is not 0.
It's an indeterminate form.
It's an indeterminate form. So this guy over here is an indeterminate form, which means we need something more powerful. You have an indeterminate form. Anytime we've encountered an indeterminate form, l'hôpital.
Oh, negative infinity over e to the infinity.
But here's where you need to be careful. You don't have to be careful with this stuff, right? You have to be careful with this idea of l'hôpital because l'hôpital is for limits. You would need to actually rewrite this and say something like, it's the limit as x approaches negative infinity of x e to the x. L'hôpital is for limits. This is an example, and I'm just going to flag it for right now, of an improper integral. We've kind of talked about this a little bit before. Okay, we did this when we talked about like the integral test, and we were comparing two to see convergence or divergence. This is an improper integral, which for right now I'm just going to flag, and we're going to stop. Tomorrow is all about improper integrals. I was kind of debating which one to do first. Okay. Here's what I really care about in this problem. Is everybody okay with like the integration part? The integration by parts we're doing okay. The evaluating part, everybody knew that you needed to do that. And then you get to this part and you're like, whoa! That's tomorrow. Whoop. All right, good. All right, see what you can do this next one. No, don't talk to me. Talk to your friends. You get smart people. Smart people abound in this room.
Oh, wait, no.
That would be for me.
I'm gonna let you dangle for a little bit here. So seeing lots of good choices. People are flipping back to the very beginning of the packet. They're like, where is that darn arctangent of x? Yes, arctangent of x does show up. Anybody know the integral of arctangent of x? No.
The derivative.
We know the derivative of arctangent of x. The derivative of arctangent of x is 1 over 1 plus x squared. But that's not the integral, that's the derivative.
That's you.
Okay. Some people might argue this isn't integration by parts. It can't be integration by parts. There aren't enough parts. Yes, there are.
Yes, sir.
You need, not that, you need a u and a dv. You need something. The u has to be something you can find the derivative of. Ah, it's the arctan. Arctan. The dv is something you can integrate.
X.
Not x. Yeah, I think some of you said arctan. Like this part. You know. The arctan is a function, it's operating on something, it's operating on x. The dv is the other stuff, which is the dx. To do this, now you need du and you need v. Well, du means find the derivative of arctangent of x. 1 over 1 plus x squared dx. dv, what would I take the derivative of to get dx?
X.
X, right? Because there's really like a 1 hiding over here. So v is x. Okay, finish off. Integral of arctangent of x dx. uv. So I'm going to write this as x times arctan of x minus the integral of v du. And really, if you did uv, you'd have arctangent of x times x. That's just going to confuse my brain. The arctangent of x times the x together, I'm going to move the x in front so I don't get it confused. Minus the integral of x times 1 over 1 plus x squared. Any clever ideas here? X times 1 over 1 plus x squared.
Oh, can you do
What do you want to do, Lewis?
fraction decomposition?
Partial fraction decomposition. I love it. Partial fraction decomposition works really well if you have, stay with me though, in order to do partial fraction decomposition, you have to have a fraction, got it? That can be decomposed. The denominator can be factored. 1 plus x squared cannot be factored. Good try. Partial fraction decomposition not helpful. Myra?
Maybe you could do the whole substitution thing again.
Like integration by parts?
No, like the
Substitution. Will substitution work here? Your regular old substitution, can I use that here? Right, if we're going to do that, maybe you want to write this as like x over 1 plus x squared dx. If you think substitution, give it a whirl. I'll tell you, if you do it right, it's going to work. What's going to be a little weird though, is we normally use u for substitution, and you've already claimed u is something else over here. W, okay. And there's nothing that says substitution has to be the letter u. It could be any letter you want to. So let w equal 1 plus x squared. dw is 2x dx. So 1/2 w
Arthur.
equals x dx. No idea what just happened there. I'm just going to keep on going. 1/2 dw over w. I've still got x times arctan of x. Half is a constant, pull it up front. 1 over w dw is natural log of the absolute value of w. So if all goes well, x times arctan of x minus 1/2 natural log of the absolute value of w, but that's really 1 plus x squared plus c. Ta-da! Life is good. I know we're going fast, but I think this is mostly process stuff, so I think everybody's good. All right, one more.
No, I am.
If you're getting a strong sense that this is integration by substitution, integration by parts, not substitution, sorry. If it's integration by parts, you need a U and you need a dv. Whatever you pick for dv, you have to be able to integrate it. If you can't integrate it, you're doomed. Whatever you pick for u, you gotta be able to take the derivative of. Good news, we can take the derivative of pretty much all the things. So I just took a quick little stroll through the room, and a lot of people have u as x cubed, and then dv must be e to the 2x dx. How many of you guys are starting your life this way with this problem? Okay. So I need du. Well, what's du? Du is 3x squared. V, I need to think antiderivative. Antiderivative e to the 2x. E to the 2x over 2, or 1/2 e to the 2x? Okay, great. So the integral of x cubed e to the 2x dx is u times v. That's x cubed times 1/2 e to the 2x minus the integral of v du. And I'm going to multiply this out and say it's 3/2 x squared e to the 2x dx. Anybody know the antiderivative of 3/2 x squared e to the 2x? Me neither.
We have to integrate by more parts.
You can integrate by parts again. Okay.
And that's why it's a special case.
Right. The 3/2 is a constant. For everybody's okay, I'm just going to take that 3/2 out. Substitution alone isn't going to do it. And Celeste kind of right away snapped to integration by parts. First of all, just like all the tools in your toolbox, you can generally use them as often as you need to. But the first thing I would want to stop and ask is, like, did the problem actually get any better? Look at where you started. Look at where we are. Did the problem get any better through this integration by parts process?
Oh my God.
Look at where you started. Look at where you are. They're not the same answer.
No, it's cute.
You started life with an x cubed, and now we're at x squared. The power went down by 1 in this process. Is life better? Absolutely, it's better. Keep going. Keep going. But be careful, because if you're going to do integration by parts, what you're focusing on right now is like this part of the problem. There's still all this stuff that came before it. So you're, in a lot of ways, embarking on a new problem. So the integral of x squared e to the 2x dx, u is x squared, dv is e to the 2x, du is 2x dx, v is 1/2 e to the 2x. Put this together, u times v, 1/2 x squared e to the 2x minus the integral of v du. V du is the integral of x e to the 2x dx. I know I'm going fast, but I hope everybody's mostly okay. Right, the brown box, we pulled it off on the side. Here's my work. This guy over here is now 1/2 x squared e to the 2x minus all this stuff. If I want to put this back into the problem, I can say, oh, all right, so what do I have now? I've got x cubed over 2 e to the 2x minus, now we need to be careful, this negative 3/2 gets distributed to this whole thing. So that negative 3/2 has to get distributed here. Imagine multiplying everything through here by negative 3/2. You're going to get negative 3/4 x squared e to the 2x. Negative 3/2 has to multiply this part too. So we're going to get 3/2 the integral of x e to the 2x dx. And I know you're like, why, God, why? Have we made any progress? Life has gotten better for us here. Life has gotten much better. We started off with an x cubed e to the 2x. Now we've got all that, and we're trying to integrate x e to the 2x. Good news, one more. One more integration by parts step is going to do it. So do it again. We're focusing in right here with integration by parts. So integral of x e to the 2x dx. Here is x, dv is e to the 2x dx. du is dx. V is going to be half e to the 2x, u times v, x over 2 e to the 2x minus the integral of v du. Pretty good. Pretty good. Integral of 1/2 e to the 2x. Integration by parts again.
No.
Substitution? I mean, we're on a roll. Integration by parts has been good to us 3 times in a row.
I don't have no case.
Integral of 1/2 e to the 2x would be, the 1/2 is a constant you can take out in front. Integral of e to the 2x is going to be 1/2. So you've got x over 2 e to the 2x minus 1/4 e to the 2x plus Charlie. That's not your final answer.
Plug it back into the.
Here is your final answer. The integral of x cubed e to the 2x dx is, make sure I don't miss it, x cubed over 2 e to the 2x minus 3/4 x squared e to the 2x plus 3/2 times all the stuff, but all the stuff is all this stuff here, so plus 3/4 x e to the 2x minus 3/8 e to the 2x, and don't forget Charlie because he's going to be really sad if it gets missed. Oh, thank you. Thank you. But don't applaud just yet. I've got one more little trick up my sleeve. And this nifty little trick is something that you do when you are encountering a problem that's going to require lots of integration by parts. And this is this nifty little trick. And we're going to see it in the Stand and Deliver movie in a couple of weeks when we watch it. And I'm going to get so excited. This used to be in Calculus AB. Sadly, it's no longer in Calculus AB. It's only moved to BC. And it's called the Tic-Tac-Toe Method. This is when you see or you feel repeated integration by parts is going to happen. Repeated IBP. Sounds like a disease. Okay. You're going to make a table that starts with x cubed. You're going to make a table that starts with e to the 2x. Whichever one will eventually, let me say it this way, which will eventually disappear with enough derivatives is what you're going to do over here. You're going to just keep taking derivatives. Derivatives until they disappear. Integrals for as long as you can. Derivative of x cubed? 3 x squared. Go over here and find the antiderivative. 1/2 e to the 2x. Come back over here, take a derivative again. Derivative of 3x squared? 6x. Integral over here? 1/4 e to the 2x. Derivative over here?
6.
Integral over here.
1/8 e to the 2x. Derivative over here? Integral over here. 1/16 e to the 2x. Stop. This is your stop. Check out your answer. See if you can figure it out. Check out that very carefully written out answer over there and look over here. I don't want to tell you anymore. I want to see if you can figure it out. Okay, fine, figure it out. Okay, so the first term is x cubed over 2e to the 2x. Where does that come from?
I mean,
It's these two guys getting multiplied together. What about the next term? The next term is 3/4 x squared e to the 2x. Here, but you have to be careful. What we have over there is negative 3/4 x squared e to the 2x. You don't get negative 3/4 x squared e to the 2x over here. You would get a positive. The next term is 3/4 x e to the 2x. That's what's going to happen here. 6x times 1/8 is really 6/8. 3/4. 6 times 1/16, 6/16, which reduces to 3/8.
That's,
So it's derivatives over here, integrals over here. You multiply on the cross, and it's plus, minus, minus. A fancier way to say that,
alternate.
alternates.
always starts with plus.
Always start with the plus. That's the trick. This is the real men and real women of mathematics would do it this way. You are more than welcome to use the trick. But I like this way too. All right, see you guys later. Yeah, color-coded, nice handwriting, ended mostly on time. Yeah. I bet this is why they're giving me another kid. Actually, I asked my wife that last night. I was like, do you think it's because I'm such a great teacher? And she's like, no. Like, do you think